Okay, welcome to our third unit. This unit's going to be dealing with fractions, decimals, and percentages. Our first lesson is going to be doing fractions and converting them into decimals. So by the end of today, we should have a review of the relationship between fractions and decimals. We'll understand the place value following a decimal, and we'll figure out the difference between terminating and repeating decimals. Number 3. I'd like you to write this down in your textbook, please. 3 can be written or represented in many different ways. And here's a couple of examples for you. The number 3 can be represented as an integer, positive 3. It can be represented in the place value of 3.0, 3 wholes and no parts after that. It can be written as a fraction, 3 over 1. And finally, it could just be written as a 3. These are all the ways we can represent that first digit, 3. You can press pause if you need to write this down. Going ahead, looking at that fraction, that 3 over 1. Whenever we see a number on top of another one, it is exactly the same as saying it divides by. So let's take a look at this one. If we say 3 divided by 1, well, how many times does 1 go into 3? 3 times. 3 times 1 is 3. We subtract and we're left with 0. So 3 divided by 1 is 3. That's pretty easy for whole numbers. But what happens when we get into the decimal places? First number we're going to look at is 7 over 10. That means the number 7 is being divided by 10. So let's rewrite that into a way that we know how to compute. There's our lovely little symbol for divide. And there's the number 7, and we're breaking it into 10 different pieces. Let's get that out of our way. So how many times does 7 or 10 go into the number 7? 0 times. We need to move forward on our, or moving to the right on our numbers. So we can actually put a decimal now because we're dealing with fractions. And there's an inherent 0 after that 7. So now we ask ourselves, how many times does 10 go into 70? The answer to that, 10, 20, 30, 40, 50, 60, 70, that's 7 times. 7 times 10 is 70. We can subtract, and we're left with 0. We can also verify this using a calculator. Let's see, now here's the number 7, and we're going to divide it by 10. What's our answer? 0.7. Okay, that was pretty simple. Let's take a look at the next one. 1 over 100. If we're going to do 1 over 100, get this one out of our way. Once again, we need to write down this equation. Here's 1, and we're breaking it into 100 pieces. So how many times does 100 go into 1? We can say 0 times. So we can add another 0 if we add a decimal here. How many times does 100 go into 10? Well, 0 times. We can't fit that. So there's our 0. Now, how many times does 100 go into 100? Once. 1 times 100 is 100. We can subtract that, and we're left with nothing. So what is 1 divided by 100? 0.01. Now let's see if we can keep following this trend here. 19 divided by 100. Draw it out. Here's our 19. Here's our 100. How many times does 100 go into 19? We can say 0. We can add a decimal place and then put another 0 here. How many times does 100 go into 190? Well, we can get 1 out of that, can't we? 1 times 100 is 100. We subtract it, and we're left with 90. Can we take 100 from 90? No, so we need to add another 0. So now how many times does 100 go into 900? 9 times. 9 times 100 is 900. Subtract it, and we're all out at 0 again. So 19 divided by 100 is 0.19. I'd like you to write those down as well. Okay. Now we're going to play with these numbers a bit more, and you're going to write this down as well. We can simply say that 7 over 10 is equal to 0.7. We can also say that 1 over 100 is equal to 0.01. We can also say that 19 over 100 is equal to 0.19. The question to you is there a trend? And think about it. Is there a trend here? Well, believe it or not, there is. The fun relationship that we can see is, if you think about it, what is 7 times 10? 7 times 10, I'm going to write this in another color. 7 times 10 is 70, which basically is a 7 with a 0 after it. But when we divide it by 10, the 0 goes on the other side. We can literally take these two numbers and turn them around with a decimal spot. Same thing with 1 times 100. How many digits are there? They're still 100, but written in reverse. Usually when you times something by 100, you add 2 zeros. This one, we reverse it. But the first 0 is always the ones place, and the second 0, so there's our first one, our second 0 goes on the other side of the decimal place. And that works exactly the same with this 19 over 100, because what it should be, 19 times 100, well, we can't really do 19 times 100 because 19 is the tens and 100 is a 0. But what we can add is, it's basically exactly backwards 190, but written in a very awkward order. While it doesn't quite work as easily for those 19s and double digits, there is a trend of going backwards. That's not something you're going to need to memorize, but if you can find these trends, it will help you along the way. What I'm going to look at right now is we're going to look at the actual place values now, going after the decimal spot. So we can have lots of numbers, which we've already written down. 7 divided by 10 would be 0.7. 100 divided, or 1 divided by 100 is 0.01. And 19 divided by 100 was 0.019. Looking at the place values. Obviously, when we go forward, we start at our unit spot. This is what we call our ones. Here's our tens and hundreds, and these are the 3 that kind of group together. And then you go into the next group of 3, which is thousands, tens of thousands, and hundreds of thousands. Then we go into millions, 110 millions, and hundreds of millions. Going backwards, it's kind of the same deal. Difference is that you don't start with, there is no point once, because anything divided by 1 comes out as a solid unit. When you divide something by 10, though, you actually get to go back 1 space behind the ones, 1 place behind the decimal. Same thing when you go back, divide something by 100, you go back to the hundredths place. And if it goes beyond that, you're ending up in what's called the thousandths place. That's a mouthful, saying thousandths, but that's what we're going to be dealing with. That is just the place value. Coming after the decimal, it goes tenths, hundredths, and thousandths. I'd actually like you to write this down. Don't have to write down the big chart, but what I will ask you to write down is this. your HTO chart, which is your hundreds, tens, and ones, and then decimal. And I give you another HTO over here, and you're going to say tenths, hundredths, and thousandths. We need to know these place values. Okay, we've looked at simply representing a fraction and how to turn it into a decimal, and we've looked at the place value of the decimal spots. Now we're going to look at the thing called terminating decimals and repeating decimals. So we're going to start off with what's called a terminating decimal. So a terminating decimal is pretty much a decimal that stops. Let's go with the first example. First example is the number 4, and we're going to divide it by 5. We need to split the number 4 into 5 different pieces. How many times does 5 go into 4? 5 times 0 equals 4. So now we're into the decimal places, and we add a 0. How many times does 5 go into 40? 8 times. 8 times 5 is 40. We subtract, and we're left with 0. Our decimal ends right here. This is a terminating decimal. Let's do that again. Okay, 3 divided by 4. 4 goes 0 times into 3. We add a 0. Get that decimal up in there. How many times does 4 go into 30? Well, we know that 4 times 7 is 28. Subtract that. Left with 2. Add another 0. How many times does 4 go into 20? 5 times. 5 times 4 is 20. Left with nothing left. Again, we stop there. There is nothing else to go with, so 0.75 ends our decimal spot. We have a terminating decimal. And sometimes our decimals don't end, and these are things called repeating decimals. So let's try 5, and we're going to divide that by 6. How many times does 6 go into 5? 0 times. So we had our decimal spot, 50. How many times does 6 go into 50? 6 times 8 is 48. And we subtract that, we're left with a 2. Sorry. 6 doesn't go into 2, so we add a 0. How many times does 6 go into 20? 3 times. 6 times 3 is 18. Subtract, we're left with 2 again. Uh-oh. Put a 0. 6 into 20 is 3 times again. That'll become 18. Subtract, we're left with 2. Add a 0. 3 times 6 is 18. And we're always going to end up this 3, 3, 3, 3, 3, 3, 3. And this will go on literally forever until we just get out of lead, out of ink, out of life. It will continue on and on and on and on and on and on. Now, we're not that cruel and unusual when it comes down to teachers. Usually what happens is, if this number is to repeat over and over forever, we have a cheat. When we write the number down, we write it down until it repeats twice. And we highlight the repeated section. The thing that's going to happen over and over again is this 3, 3, 3, 3, 3, 3, 3 thing. So we write a line over top of these 3s right here. And that is how we end it. We say that 5 divided by 6 is 0.833 repeated. And that bar above the 3, 3 is what tells us that it continues on and it repeats forever. Here's your homework for today. Take a look on page 88. I will ask you also to take a look at the actual lesson from the textbook on page 86 and 87, as a lot of those tricks in the book can help you as well to solve these problems. Good luck. I'm expecting you to ask me lots of questions when you need help.